All right, let's jump right into this explainer and explore the absolute awe-inspiring limits that actually govern our cosmos. When we look up at the night sky, it is so easy to imagine space as this infinite, anything goes kind of playground. But it turns out the universe isn't some lawless frontier at all. It's actually bound by an incredibly strict rulebook, one that dictates exactly what can happen, what we can see, and honestly, what's even allowed to exist.
So, does the universe actually have a speed limit, a visual edge, and a censorship board? Well, that is exactly what we're answering today. We're going to look at how the cosmos imposes these hard boundaries on energy, on observation, and literally on physics itself. We're going to unpack the science behind three mind-blowing cosmological phenomena that prove our reality actually has a ceiling, a definitive edge, and, get this, a built-in mechanism to cover up its own flaws. Here's our roadmap for today's explainer. We'll start with the universe's rulebook, hit the ultimate speed limit, move on to the boundaries of sight, look at the future we cannot see, dive into censoring the universe's secrets, and finally wrap up with the edge of reality. So part 1, the universe's rulebook and the fundamental limits of reality. Which brings us right into part 2, the ultimate speed limit, or hitting the cosmic wall. Now, we often think of space as this massive, empty void, right? But the source material shows us it's actually filled with these unbreakable physical barriers. Let's take our first rule, which restricts the speed and energy of particles zipping through space. You've probably heard that the speed of light is the universe's ultimate speed limit. But there's actually another, lesser-known limit that applies to the physical matter flying through the cosmos. It's called the GZK limit, and it basically acts as cosmic drag. See, extremely fast particles eventually crash into the leftover light from the Big Bang. Space is literally bathed in these ancient photons, called the cosmic microwave background. To a normal, slow-moving object, they're completely harmless. But when a high-energy cosmic ray, like a proton, travels fast enough, the rules of the game change entirely. Think of it like driving a car through a gentle rainstorm. If you're cruising slowly, the raindrops just gently tap your windshield. No big deal. But if you were driving at supersonic speeds, those exact same tiny raindrops would hit your car with enough kinetic energy to completely shatter the glass. Because of something called the Doppler shift, these super-fast cosmic rays perceive that low-energy background light as highly energetic gamma rays. The collision literally shatters the cosmic ray. So basically, the universe has built itself a natural speed trap to prevent matter from traveling infinitely fast. But here's where it gets crazy. While normal cosmic rays obey this limit, there is one exception that was so completely baffling, physicists literally named it the "oh my god" particle. In 1991, a single microscopic proton slammed into Earth's atmosphere, moving with the kinetic energy of a fast-pitch baseball. I mean, it completely broke the universe's rules. How on earth did it get here without being obliterated by the cosmic microwave background? It's still one of the greatest astrophysical mysteries out there, and it really reminds us that just when we think we've got the rulebook figured out, the universe loves to throw us a curveball. All right, moving on to part 3, the boundaries of sight and looking into the past. So as we zoom out from those tiny subatomic particles to the scale of the entire universe, we run into our second major rule, observational limits. Just like matter is restricted in how fast it can travel, we, as observers, are severely restricted in what we're actually allowed to see. The particle horizon represents the absolute hard edge of our past observable universe. Because the universe has a finite age, around 13.8 billion years, and because light travels at a finite speed, we can only see objects whose light has actually had enough time to reach our telescopes. Everything beyond that specific distance, it's completely invisible to us right now. Take a look at the blue lines on this graph. They represent the strict mathematical boundary of everything we can currently see from the past. Now, over time, as light from further and further away finally reaches us, this particle horizon does expand. That means tomorrow, the observable universe is going to be ever so slightly larger than it is today. We're constantly receiving new light from the deep past. But as our source material on cosmological horizons explains, that's not the whole story. Which brings us to part 4, the future we cannot see, the ultimate barrier. Okay, so while the particle horizon is all about what we can see from the past, there is another horizon that dictates what we will be allowed to see in the future. Because the expansion of the universe is accelerating, the event horizon marks a genuinely tragic limit. Objects passing beyond this point will never be seen by us again. Ever. Dark energy is stretching the very fabric of space faster and faster. So if a distant galaxy gets pushed away from us at a speed exceeding the speed of light, any light it emits today will literally never, ever reach us. These complex mathematical curves you see here actually represent a pretty profound philosophical truth. That blue line, that is the absolute limit of what will ever reach us, which means parts of reality are forever slipping away. According to the research, because space is expanding so rapidly, more and more objects are disappearing beyond this boundary every day. Once they cross it, they are entirely locked out of our reality. No signal, no light, no information can ever bridge that gap again. So to put that into perspective, while the particle horizon expands to show us a little more of the past, the event horizon dictates that some distant light is already lost to us forever. We are essentially living in this temporary, highly privileged window of cosmic time where we can actually see the glorious structure of the cosmos. Because trillions of years from now, future observers will look up into a completely dark, empty sky, totally cut off from the rest of the universe by this horizon. All right, let's get into part 5, censoring the universe's secrets and hiding the flaws. Finally, we reach our third rule, and this one deals with what happens when the very laws of physics completely break down. Because the universe doesn't just limit our speed and our psyche, it actively covers up its own paradoxes. You've probably heard of a singularity, a point of infinite density. If one of these were naked or unshielded, it would expose the total breakdown of general relativity to the outside world. Now, we know that at the center of a black hole lies a singularity, right? A place where gravity is so intense that our current understanding of physics just stops making sense. Space and time are absolutely crushed out of existence. But normally, these singularities are safely hidden behind a black hole's event horizon, so no information about this broken physics can ever leak out into the rest of the universe. But what if they weren't hidden? Without the universe stepping in to act as a censor, the consequences would be bizarre and honestly incredibly destructive. It would unravel the predictability of reality itself. Think about it. If a naked singularity existed, just a point of infinite density sitting out in open space without an event horizon wrapping it up, an observer in the external region could actually look at it. This means totally unpredictable, physics-breaking information could pour out into our universe. It would completely destroy the fundamental concept of cause and effect. And this brings us to something called the weak cosmic censorship hypothesis. Proposed by physicist Roger Penrose, it basically suggests that reality has a built-in mechanism, like an actual cosmic censorship board, that forbids naked singularities from ever forming from regular initial conditions. The universe effectively quarantines its broken physics so that the rest of the cosmos can just continue to function rationally. So why does the universe hide its flaws like this? Well, the research shows that these extreme, universe-breaking singularities are heavily constrained from ever being naked. If you look at the math rigorously, nature consistently steps in to prevent these incredibly destructive points from being visible. They are fundamentally forced to stay hidden. It's almost as if the universe completely abhors exposing its broken physics to the light of day. And that leads us to our final section, Part 6, The Edge of Reality and Living Within the Limits. Okay, let's bring all of these dense astrophysical concepts back down to our own existence here on Earth. From the microscopic particles bombarding our atmosphere, all the way to the absolute edges of the cosmos, we are bound by an incredibly specific set of parameters. We're confined by the GZK limit, we're blinded by cosmological horizons, and we're protected by cosmic censorship. So as observers trapped inside these horizons, I want to leave you with this provocative thought. What other incredible secrets exist just beyond the limits the universe actually allows us to see? We are basically sitting inside a bubble, protected from infinite energies, shielded from broken physics, and granted only a highly restricted view of the vast cosmos. It really makes you wonder, what does reality actually look like from the outside looking in?